Hello guys, welcome to the continuation of our lesson on exact differential equation. Today, we are looking at solution to exact differential equation. Remember, in our previous lesson, we learned that a first order differential equation of the form m at x y dx plus n at x y dy equals 0 is exact if there exists a particular function u at x, y such that when we find the partial derivative of the function u with respect to x, it gives us m at x, y. And also, when we find the partial derivative of the function u with respect to y too, we are going to get n at x, y. What this means is that this given equation, m at x, y dx plus n at x, y dy equals 0, represents the total differential of u at x, y. And we can solve for this equation by finding u at x, y equals c, where this c is just an arbitrary constant. So now let's look at the procedure involved in solving solution to exact differential equation. Example. Actually, this is a past examination question, so let's look at the solution. First of all, we need to identify m and n as stated over here. And it is clear that m equals 2x minus e power 3y. That is the coefficient of the dx. And n is also multiplied through negative 3x e power 3y plus 3 cosine of 3y. So this is m and this is the n. At this stage, we need to find out whether this particular differential equation is exact or not. In doing so, we need to find the partial derivative of m with respect to y, which is equal to this goes to 0 and this maintain the function, that is e power 3y times ln of the base, that's ln e, and the same as 1 times differential of function within function, that is 3. So this is what we are going to get, and we find the partial derivative of n with respect to x. The whole of this will go to 0 because it's a function of y, but at this particular point we are going to get negative 3e power 3y because it's function of x, so this will go to 1. Since del m del y is the same as del n del x, then the differential equation is exact. So now that you have established that it's exact, you need to find the potential function u at xy. And we established that del u del x is the same as m at xy, or del u del y is the same as n at xy. So you can choose either of these to work with. So let's choose the first part. So del u del x is equal to m at xy, that is 2x minus e power 3y. In order for us to get the u, we are going to have del u equals 2x minus e power 3y by del x. Just multiply this by del x. So we integrate both sides, which is clear that integral sign cancels the derivative sign. Hence, u, which is a variable of x and y, equals, now we have to integrate this with respect to x. So this will give us x squared on 2 on 2. That will still be the same. Now, integrating this, you're going to get, it is a constant, so we have x e power 3y. So this is what we have. But we need to add a function of the other variable to it. That's a y. After this is done, we need to determine this particular constant f at y. And in finding the f at y is a function of y. So we have to differentiate the whole thing again with respect to y. We are going to have del u del y equals, this go to 0. Over here we are going to have negative x. When you differentiate this one, this will be 3 e power 3y plus, when you differentiate f at y, we are going to get f prime at y. Note that initially we established that del u del y is equal to n. So it means the whole of this is the same as n at xy. You see, negative 3x e power 3y plus f prime at y is equal to n, which is negative 3x e power 3y plus 3 cos 3y. And of course, this cancels this. Now we have f prime at y equals 3 cos 3y. In order to get f at y, we integrate with respect to y, dy. So this gives, when we integrate this, we are going to get 3 on 3. That's when we let this one to be u, sine the same function plus c. Finally give us sine 3y plus c. So now we can go and substitute sine 3y plus c over here and our solution become complete. We had u at xy equals x squared minus x e power 3y plus f at y. I've gotten the f at y to be sine 3y plus c. Substituting our solution, x at y equals x squared minus x e power 3y plus this sine 3y plus c. But note that we said that u at x, y is equal to the arbitrary constant, hence the whole of this is equal to c, and that's our solution. Second problem. So this is our second example, and it looks very nice. We need to identify m and n, and we know that m is the coefficient of the x, and that is y squared e power x plus xy e power x plus y e power x, and n is also x e power x plus 2y e power x. Now we have to find out whether this differential equation is exact or not. In doing so, we find del m del y gives us with respect to y, so it means this acts as a constant. So we are going to get 2y e power x, we are differentiating this, plus with respect to y, only this y another constant, so we are going to have x e power x, and then this y and a constant, so we are going to get e power x. So that is for del m del y. Now del n del x, with respect to x, the whole of it acts as a product. Let's differentiate the x. We're going to get e power x plus, now let's say differentiate, maintain the x and differentiate this one. We're going to get x e power x. When differentiate e power is the same thing, plus now differentiate this, which will give us the same thing again, 2y e power x. So now let's compare whether it is the same. Yes, we have this, and we have that, it's the same, so it says that since del m del y is the same as del n del x, then the dE is exact. So now that is exact, as we established, we can now let u at xy be our solution. So we established that when we find the partial derivative of the u with respect to x, that should be equal to the coefficient of the dx, this, and that is the m. So we are going to have y squared e power x plus xy e power x plus y e power x. Now we need to find the u at xy, and in doing so we are going to have y squared e power x plus xy e power x plus y e power x all del x. Then we integrate both sides. This cancel that, and now our u at xy is. So now let's integrate this with respect to integrating this with respect to x. We are going to get the same thing because the integral of e power x is the same thing. So that will be y squared e power x plus. Now we're going to integrate this with respect to x. Over here, you have to apply the idea of integration by parts. Let's do that. You have u, v, and product x. When you differentiate again, we're going to get 1 and 0. You have e power x, e power x, e power x. So this to this to that, we are going to get this will give us x e power x, and this will give us e power x plus minus. So that simply means that the integral of x e power x is the same as x e power x minus e power x. So that's what we are going to get for this, multiplied by the constant y. We are going to have x y e power x minus, then the y by that, so we are going to get y e power x. Also integrate this with respect to x, and it's the same thing. That's y e power x plus a function of the other variable at y. But note that this is the same as this. Finally, u at xy now becomes y squared e power x plus xy e power x plus f at y. We need to find the f at y. So in that case, we are going to differentiate this partially with respect to y. So we are going to have del u del y, which is equal to, so with respect to y, this constant. So we are going to have 2y e power x plus x e power x, the y will be 1, plus f prime at y. Del u del y is the same as the coefficients of the y. So we are going to equate this to the coefficients of the y. We have 2y e power x plus x e power x plus f prime at y equals x e power x plus 2 e power this. You can see this is the same as this is the same as that. So f prime at y is equal to 0. Integrate f prime at y, the integral of 0 dy, and that will be f at y equals constant c. Hence our u at xy equals y squared e power x plus xy e power x plus c. But we know that this is the same as that, so finally our answer is y squared e power x plus xy e power x is equal to c. That's that. So this is the end of our lesson on exact differential equation. In our next video, we are going to look at a situation whereby it is not an exact. Thank you very much for watching. Share to your colleagues. Bye bye.